Good morning, friends. Welcome back to host-tune-perform.com. So, in the previous chapter, we discussed about infrastructure monitoring, and like I told you, that SNMP is a very important protocol. It was the first protocol which was built up for infrastructure monitoring, and like it is being used widely within the industry, specifically to monitor the network devices. So what do we mean by that, and like what is the architecture and what all things can SNMP monitor? We will talk about it. We will not talk about RMON in this tutorial. We will be specifically working and like studying deep dive into SNMP. So what exactly is net SNMP, and how does it work? So the first thing which you need to know today is like NetSMP is something which works on UDP IP protocol, which is user datagram packets. So it is not TCP IP based, it is UDP IP. And like UDP is a protocol which is not much reliable than TCP, because TCP gets the acknowledgement back while UDP does not. But this makes it faster, and like as this is not a software which is used for applications, so in monitoring, like UDP seems to be the best option. So that's why like I think that this particular protocol is based on UDP IP protocol. So in this tutorial today we will talk about SNMP architecture. Then there is a very important concept, like this particular tool works on this process, which is MIB and OID concept. So just to give you a reference and trying to make it easier, what is MIB? MIB is nothing but a text file. So people call it management information base. So this is no more than a text file, and in this text file we have a lot of entries, and these entries are in numbers, something like dot one, then dot two, then dot maybe six, then dot three. So these are the entries which are made in this MIB file, and there can be something called as the name. So this particular structure has a name, so this can also have the name. So something like this. So this is nothing but a text file, and this entry which is present inside this MIB file is called as the OID, which is the object identifier. So we'll talk about it. It was very necessary for you to know at least this much about MIB and OID before we start working on it and start seeing the architecture of it. So that's why like I just wanted you to know about it. Then we will talk about SNMP versions, and at the end we will have a SNMP practical demo. So this demo will come up from Windows. We will be monitoring from Windows, and what we will monitor? We will monitor a virtual box having Ubuntu. So we will be monitoring Linux, that is Ubuntu, and this is how like we will proceed in this particular tutorial. So the next thing which brings a lot of interest about understanding of this protocol is how exactly this protocol works. So to let us understand it, let us first concentrate on some headings which are H1 and S2, which are written out here, right? So these H1 and S2 are nothing but the hardware. So what I mean, like in a normal scenario, when we say that we are into a company will have a lot of things, like there will be a one system over here, then a router over here, then again another switch over here, and then a bunch of system or mobile connected to the network over here, and then we may have a LAN VPN created up for this entire like thing, and then there can be another office, and in this office we can have again a lot of computer systems, and then again a lot of network devices. But at the end, when you are saying that you are monitoring up all these network, you need a server. Say you have a server over here, this server will monitor each of these device, and they will inform like about their status to this particular server. right? So these boxes can be a desktop, like which can have Windows or Ubuntu, or these like particular boxes can be network device such as a router or storage device or a printer or maybe a switch. So these can also be monitored using SNMP protocol, but this particular thing like binds up with a particular box out here, and this line actually represents the connection between these two boxes. So why I am telling you that this particular line represents the connection between these two boxes, because we have to install separate softwares on separate hardware. So when we say that we are monitoring up this box, or we are monitoring up this box, or we are monitoring up this box, or we are monitoring up this box, so it be any hardware, may it be router, may it be printer, it should happen have a software installed which is SNMP agent. All of them will have their own SNMP agent installed on their hardware, and this particular agent will work with this particular box out here. And if you see up this box, this is the manager, SNMP manager. So this is installed only on one system, which is collecting up the data of all the monitoring targets. So if I come back to my picture, you see we have just two hardwares, which is hardware 2 and hardware 1. So this particular picture depicts one connection, like this one connection, this box and this box. So we are not talking about the entire structure. Let us first understand how this protocol works by having one agent and one manager. So if I come back to my diagram, so we have these two hardwares, and this is nothing but the OS. It can be Windows, it can be like uh, Ubuntu or any other Linux distribution or any other OS you want. You just need to go ahead and install the SNMP manager, which is what it is written out here. And this SNMP manager, after you install it, like this can talk to any agent which is present. So one of our hardware is this, which is hardware 2. On this hardware, we will have to install SNMP agent, and obviously we need to configure it. Again, we need to configure the SNMP manager. So we will talk about it, how we will configure it. But these are some basic steps which are like being performed in any sysadmin work. So you should know that if this particular hardware needs to talk with this particular hardware, this hardware 2 should have the like a address file where it can connect, say like, okay, I have to connect to H1, where for hardware 1 you will have the IP address, then you will have the port, or maybe some other requirement if required for security level. So that depends. So next is like, on what all systems can this SNMP agent be installed? It particularly depends on the maker. This is just a software which can be embedded on the firmware of any network device. When this particular firmware is installed on a device, that device become costly. So if you see a router from Cisco, you can get a router which supports SNMP, or you can get a router which does not support SNMP. If it does not support SNMP, obviously you will not be able to like monitor it using SNMP because the agent is not installed. But at the end, on any network device, you yourself do not have to like do any installation of this particular agent, but yes, you have to configure it. But no installation is required on any network device. But yes, if you are installing and like monitoring some Windows, or you can say like Ubuntu distributions or Mac, you might have to enable it. So in Linux, you have to install it using sudo apt-get install, obviously. In Mac and Windows, you have to enable it. In Windows, it is in Windows features. You can just type in over here and say Windows features, and you will get a window out here. And in this window, you should look for SNMP. So there must be somewhere, I will have to check it myself. So you can just Google it out and see where it is. But yes, in Windows, you will have to enable it and the agent will get enabled. So at the end, like you can monitor almost anything and everything. The intention it should be SNMP enabled device. But you can say like you are monitoring a Linux box, but inside an Ubuntu box what all things you are monitoring. So can you monitor CPU? Can you monitor uh, disk utilization, or can you monitor its uptime, or can you see the system name? So all these things in Ubuntu, can you monitor them? The answer is yes and again no. Why yes and no? No, because if you just install the daemon, SNMP agent is also called as SNMP daemon. If you just install the daemon, so on Ubuntu, the agent itself supports very less OIDs. So like those mostly belong to either the system OID or the HR resources. Few of them, two, three of them. So if I count them, I should it should not be greater than 25 OIDs. Also, it means that you cannot monitor more than not even like I think 15 if I remember it right. So so there are some extensions to the agent, like we call as agent extensions. So this is being provided by SNMP. So before going ahead and like talking about it further, let us first try to understand how exactly this works. So now we have the network management system and we have the monitoring target, and we know that we have taken just one monitoring target. There will be a lot of them. So how the communication happens? So the first way is SNMP polling. So this is the first way, and this is nothing but SNMP polling. So this network device will connect to this monitoring target, and like this connection can happen by SNMP protocol version 1, 2 or 3. We will we will see the difference between them in the upcoming slides, but as of now just understand like uh, all of them are widely used. SNMP 2 and 3 majorly are widely used in the industry, and functionality wise they do not have much difference. The major difference just lies in the security aspects. So now let us talk about SNMP polling, which are these CLI commands. So you need to open up the command prompt on your system where you have the SNMP manager installed, and in this OS, go to the command prompt and like just type the command such as SNMP get, SNMP get next, and then it will ask like you also need to enter the parameters. Say for example SNMP get space, and then after space you will just write down the community name, and you also need to define the version before community name, that is dash vc, which is version v2c, which is version 2 and community version. And at the end like you will be like just giving up the IP address of this particular machine. So we will see all these things in practical. So from your command prompt, you will just type a command which will have all the information about this particular agent, and you will hit the enter, and this particular request will go to this particular agent on port 161. So the polling is done on port 161. So why I have written any port over here? Because you are sending up the request from command prompt. So it does not matter from which port you are sending up the request. The response will come to the same port, but it will go to port 161. So this is the polling mechanism. But in this mechanism, the server, which is centrally managing so many devices, this server, so which is centrally managing so many devices, is actually like getting burdened because it has to send the request to each one of them and like get the response back. And like this is not a real time, because every time it has to go over here and check, oh, are you there? If it says yes or no, it will like come back. If it says yes, it means that it was working fine and there was no requirement of checking it. But this is how like this particular protocol is built. Then the second thing is SNMP traps. So to cover this aspect, which says like we were not in a real time system, what will happen? Like there will this agent will itself see all the parameters. So it has all the check mechanisms which are kept on over here. So it will itself see all the mechanisms. So it will see the CPU. If the CPU is like above 80%, it will automatically like send in a request to this particular manager and say like, oh, I am running out of CPU, please uh, like look after me. So in this particular case, this particular software or check is implemented on the agent. So we have to configure the traps. So this configuration is done on agent, because the agent should know what to check and then where to send the information. Like it needs to know where is the manager. and it sends the request to port 162 and it does not receive any acknowledgement. So after sending up the request information that the CPU is gone above 80%, it will just send the information and it does not care what happens. And this is the difference between SNMP traps and SNMP inform. In SNMP inform also you will have to like set the inform on the agent. You will have to configure it on the agent, and after you configure on it on the agent, it will send the request, but this time it will wait for acknowledgement. This particular line is just for acknowledgement. Oh, I have received your intimation and I have also informed the developers, something like this. And if we go ahead further and talk on it, there is one more thing which I want to talk on this particular window. So let me clear out everything, and now if you see over here that we have a text file which is MIB, and we need to discuss how exactly this works. So we have discussed about two software which is SNMP Manager and the second is SNMP Agent. So SNMP Agent has a pre-installed tree structure of all the elements which it can monitor inside the monitoring target. So if the monitoring target is Ubuntu, it will have a tree structure of what all it can monitor. So in my case, when I say that SNMP supports very less monitoring target in Ubuntu, I mean that it is only 15 or 20 targets, and like those are all are also not very necessary. But this is what is loaded in SNMP agent. So there was a need of extending this particular tree. So this is known as extension of the SNMP agent. So when we say that we have extended up the SNMP agent, we are like increasing its capabilities. But what all things will the SNMP manager be able to like target and monitor? Only the things which are defined in this tree. Now this tree has some OID number. So this particular MIB file is nothing but the list of all the OIDs which they have extended. Say Cisco has its own MIB list or OID list, Switch has its own, and like similarly Synology has its own. So these have their own MIB files, and these MIB files are given up to you people, and like we people add it or load it in the SNMP manager. What this file does is like this is just the repository and is being used only by the SNMP manager. It does not have any use or any like work with this below agent. Agent does not use this file. No, this file is only used by SNMP manager. And why it is used? Because in actual all the work is done by using these OID numbers, and these OID numbers are very big and like represented by a lot of dots. So this file is needed to convert these names into OID numbers, and after that like this SNMP manager sends these OID number to the monitoring target, and this monitoring target returns back the response, and this response is again like checked in this file, and if it has a name, the name is also put up. But if this file does not have a name, the SNMP manager will be showing up this name. But this file is particularly used for SNMP manager to manage the UI, but the values of this file come from this tree. So how we form up this OID and like how exactly this tree is formed, we will discuss about this in more detail in some time. But as of now, you need to understand is whenever you like hit this command gets to the SNMP agent, and this SNMP agent says like this command is asking for the information in a particular OID. SNMP get asks for information in a particular OID, and it will check this OID is present over here, and this present OID will have an associated information, and this associated information will now given up to the manager. So the manager will know, oh, the current CPU utilization is 60%. That is okay now. That is perfect. So this is how this works. The tree structure is very important. The ports are very important. Like SNMP trap is received on port 162. Again, what all things can be monitored is very important, and an OID is always attached to an information. So OID is nothing but what we are monitoring on that particular device. So if we are monitoring something that particular thing will have some information. Like if you're monitoring the CPU, it will have CPU utilization percentage. If you're monitoring the disk, it should have disk. If you're monitoring the system name, then we should have a name. If you're monitoring the time, then we should have a time value. So in the similar way, like this gives you most of the things which an SNMP can do, and like why it is so famous and being used widely is like the reason is like we can like the companies can write up their own MIB and OID, so they can extend this tree anyhow they want. They can like extend it like this or this and this, and like attach all OID to some information. So there is a code written over here, and like for most of the time in like 99% of the cases you will not have to write up this code as a system admin. You will just have to use up these commands to get these MIBs. And even for Ubuntu we have few extensions already built up, like net SNMP, which is this particularly has built up extension for Ubuntu. So let's go ahead and discuss something about the tree now. So everything in SNMP is stored in a tree structure. So there are a few important things which you should know about this tree structure. So most of it is already like prepared, and like there is a very less requirement of like extending it. And like if even if it is like required, then it is done by the hardware companies in the major case. Not if you are looking out for some specific requirement on Ubuntu or doing some custom work, that is a different case. But this tree always starts with a root node which does not have any like a number or name assigned, and then we have other nodes. So this is a node which is the child of root node, and it will have one name string. So the name is the string part and the number part is the second part, which is this. Then it again has a child which is org, then it has a child which is dod, which has a child which is internet, and this internet has these few childs. The point which have to you have to see over here is like within this particular like sibling area. So directory management, experimental, private, these all are the siblings and children of internet. So they cannot have same name or same number. If directory has number one, management cannot have number two. If this number two has name management MGMT, direct number one cannot have the name MGMT. So they will remain unique. So this is what this says, and every node has a number or lane. So in a similar way, root node can be attached with other uh, like nodes, but the root node is always required by SNMP. So this should always be there, so that the SNMP software knows where it needs to go, because this is the first place where the agent can like hit up SNMP walk to know what exactly it can monitor. Then if you see that all, like why I'm saying it, all these are like predefined like nodes, because if you see over here that in private we have enterprise and you see that Microsoft, so this name has not been written by me. So I have not imagined it. This is what how the tree is. And like in ISO, that is Internet Standard Organization, or like whatever it is, then we have organization, then DOD, then internet. For internet, like for private we have Microsoft, and this Microsoft has the OID number which is 311, and then it will have its own childs. Microsoft says my all my OIDs will remain under my tree. So this is how like you are managing. So SNMP treeing structure is nothing but the index. It is the way to index the huge amount of data which will be coming up from different vendors and like so many different companies. And like if you are saying you're monitoring up so many things using the same protocol, this diagram is very important. And in the similar way, there are thousands and tons of MIB requests which can be taken upon. So if I just show you up, there is a glossary which I have like mentioned up over here. If you see this image, it has a URL which is albestran.number. Let me just go ahead and open this for you. Okay, news and then content. Okay, then here, and I will just copy it. and paste it. So you see that this is a website which is designed by this person, and he has listed down all the known OIDs and the structure. You can see the structure out here. If I just compare it with the structure over here in this image, so if you see over here that at very first we had, okay, so you can see now. So on one we have ISO. So you can see one we have ISO, and two we have joined. So this OID might be like used by some other company. So in the similar case, 1361, which is 1.3.6.1, is for internet OID. And if I just go inside this internet OID, so at 1 it has directory, at 2 it has management, at 3 it has experimental, at 4 it has private. If I go to private, I will surely find Microsoft into it. So uh, so if I just see over here, and I just clicked on private, and this is the private one. Let me click on this, and here I reached. So this has now 1361, and we have 4. So I do not want to see the 4 path. Let me just, so this is for enterprise store in the INF file. It says this. So I can maybe go over here, and now I can see up this all, like you have OID list for so many companies, and like they are doing so many stuffs. In a similar way, you can have OID for different like areas. So if you want an OID maybe for some other reason, maybe for LDAP, so it is 1.1, you can see out here. So like there are no limitations out in technology, and hence this string structure is becoming complex day by day. But the point to remember is like whenever you're monitoring any target, so that target will specifically provide you with the MIB file. All you need to do is just load it, and you will be get going. So the next thing is like you should always look for a MIB browser. So this is also a place where you can find up various OIDs. So if you see out in my case, I have downloaded Manage Engine MIB browser. Let me zoom in. Manage Engine MIB browser free tool. I have downloaded of this tool. If I go to edit and settings, in the settings tab, if I go ahead and show you up this particular template settings. So now if you see up this template settings, so in this template setting you can see so many templates. So you can see so many monitoring system OIDs. So again, like there are various ways you can find these OIDs as per your needs. All you need to know what you are monitoring, and the company should always like also provide you the same. For example, if we are monitoring Linux, so in Linux we have these OIDs. Below are the OID numbers, and above one are the names. So this complete OID is can be represented by above name, which is this monitoring graph, and this OID is for monitoring graph. Again, for process count, we will have the last OID, which is this, which is for process count. So I just need to copy it and like paste it over here, and like I can just hit an SNMP get command, and the value for this particular OID will be shown. For example, if I just show you up, so I can just see these particular things as of now on Linux, because I have not extended it with net SNMP. But if I want to see the value of this particular thing, so I can just copy it and just press this button. So this particular thing has the value this is like system description. What system this is? This is a Linux system, and the name is host tune perform virtual box, and there are so many other details. So this is how like this particular protocol works, and this was a discussion about SNMP tree, which is very important and obviously the complex part of this scenario. One thing which I want to discuss more is like something about traps which I may have missed. So whenever you are sending in a trap and like this manager receives a trap, so there should be some mechanism with this network management system, that is NMS. So this network management system should work accordingly to this information given by this trap. It can like trigger an email or put an entry in database, and this database can be checked further. Obviously all the values which we come up from SLI commands are also put up in this database, and this database can be looked upon further using some visual tool like Grafana. So there is no limit to the extension of this protocol, and like why it is so popular is because of its formation and like its speed. So the next part which we will cover up today is SNMP versions. So we have already discussed few things about version, and like this will be a very short discussion. So it basically have three version: SNMP version 1, SNMP version 2, C means community, and SNMP version 3. So obviously there was version SNMP version 2 A and B as well, but they are not used much. Then we have like access control using an MIB view. What is MIB view? Like your agent is having tons of trees, like a hell lot of big tree, and you want a user like should be able to see only a part of the tree. So you will create an MIB view and say that only this part belongs to this view, and you will assign that view to the user. So this is how like the access control is done, and like the second is the community, which is nothing but the password for 1 2, and but like these community password was very like unsafe to use, and hence they increase the privacy and like the security in version 3. So functionality wise there is no change, major change between all these three protocols. Only like difference is like this inform is not supported in version like 1, or else functionality wise trap works on all of them, inform works on 2 and 3, and then the major difference is between this, which is authentication and privacy. So the authentication and privacy is done using the community name in version 1 and version 2. So you will be more comfortable with like these names and like how we use them when we will set up the environment on Ubuntu. Let's take up the theoretical knowledge today, and we will talk about the demo in the next chapter. So this particular version of SNMP3 can have authentication using MD5 or SHA, and the privacy using DES or AES, which are the like widely used algorithms. And this like brings up this lesson to the close. And in the next chapter, we will be doing up the practical part on SNMP, which should be really exciting for you guys. And we will be monitoring Ubuntu from a Windows via SNMP. Thank you guys. Have a great day.